Hi everybody, and welcome to video number 1 of our Unit 4 video series. We're going to introduce some vocabulary about solutions and also explain how to interpret solubility curves. Let's get some basic things out of the way. What is a solution? A homogeneous mixture of two or more substances to form one single phase. This is a physical change, not a chemical change. The two substances you mix keep their identity. There's lots of different kinds of solutions. Most people don't even realize there can be this many types. If you think about alloys, we've talked about them already. That's two solids mixed together as a solution. The classic solids dissolved in liquids, like the salt water at the beach. Anyone who says they're drinking alcohol is really drinking two liquids dissolved in each other, alcohol and water. Fizzy aerated beverages like soda, that's a gas dissolved in a liquid. Also, just the air you're breathing is multiple gases dissolved in each other. Also, a liquid dissolved in a gas, which would be the water vapor. Some simple vocabulary now. Obviously, we have to start with solute versus solvent. I always say this sentence in my head to tell the difference. Solutes always get dissolved in the solvent. So my example on the right, water and salt from a salt shaker. Since the salt gets dissolved in the solvent, the salt is the solute and the water is the solvent. You might also remember there's limits to how much solute can fit in a given amount of solution at a given temperature. For this water, which is 250 milliliters at 25 degrees Celsius, can hold about 88 grams of sodium chloride. So if we put in 40 grams, would that solution be saturated? That's like saying, does it have its maximum amount? Of course not. It can hold another 48 grams. If you put in 60 grams, still not saturated. 80 grams, even still not saturated. You could still dissolve 8 more grams. Finally, at 100 grams of salt added, it's going to be saturated with 88 grams. The remaining 12 grams are actually just going to sit in a little pile on the bottom of the beaker. You might also remember that these saturation limits can change with temperature for most solutes and solvents. If we take the same water and heat it to 50 degrees, it's going to be able to dissolve more, up to about 92 grams of sodium chloride. In order to summarize these different changing solubilities at different temperatures, we use something called a solubility curve. It's simply a graph that shows the amount of solute required to make a saturated solution at a whole range of temperatures. When you see this, normally the curves will specify a certain amount of solvent. In this case, it's going to be 100 grams of water. Here's your first solubility curve. Notice left-hand axis, grams of solute per 100 grams of water. Down the bottom are the temperatures. The types of questions you can be asked. We'll start with this one. What is the solubility of potassium nitrate in 100 grams of water at 60 degrees Celsius? Find the temperature 60, follow it up to the KNO3 line where it meets, follow that over, you hit at about 105, there's your answer. About 105, 106 grams of potassium nitrate can saturate a 100 gram amount of water at 60 degrees Celsius. Here's a different type of question. At what temperature do potassium nitrate and sodium chloride have the same solubility? Here's the KNO3 line. Here's the sodium chloride line going across this way. Wherever they meet, at that mass and temperature, they have the exact same solubility. That temperature corresponds to, I'm going to estimate maybe around 24. 24 sounds pretty good. A little more complicated here. This question says, how much potassium nitrate will dissolve in 50 grams of water at 50 degrees Celsius? For the first time, we have a mass of solvent that is something other than what this table specified for. This table's for 100 grams. The problem's asking about 50 grams of water. The masses are proportional, so whatever mass can dissolve in 100 grams of water, exactly half of that will be soluble in 50 grams of water. So find your temperature, 50, go up to the line, follow it over. I'm going to guess maybe around about 84 grams of potassium nitrate. Split that in half, and you end up with about 42. Final question says, if you have 100 grams of water that's saturated with potassium nitrate at 0 degrees Celsius, and then you warm the solution to 65, how much more could be dissolved? So start where the question starts. Down at 0 degrees Celsius, if KNO3 is saturated, it can hold about 15 grams of the salt. If you increase the temperature up now to 65 degrees Celsius, however, and follow that line up, of course, you can dissolve more. You can dissolve about 120 grams of KNO3 there. So if you start with only 15 grams, and then you increase to allow it to hold 120 grams, the difference which I would guess at about 105 grams, that's how much more KNO3 you can dissolve in that solution. Finally, it's worth mentioning that some substances can go beyond their saturation limit. If this happens, we call a supersaturated solution. On the graph, this would be any substance that has a mass higher than its saturation limit line. Typically, the way you do this is to make a saturated solution at a much higher temperature, and then you let it cool down. And if you do it nice and slow and you don't bother, you don't touch it, sometimes as you cool it, it will still keep all that greater amount of solute dissolved. So now all of a sudden you're back at 25 degrees Celsius, but you have all of the original solute dissolved. So that is now a supersaturated solution. A lot of these things are very unstable. You can trigger that extra dissolved solute to come out of solution and re-solidify if you bump it the wrong way, or if you put a small particle of solid back into the solution. That concludes the video. Please enjoy the recap to follow.